Okay, this following questions asks us to find the absolute max and min on this interval, and the interval is -2 to 0. So it's very simple to test this. All we need to do is take the first derivative, set it equal to 0, figure out where those points are. We need to plug all those points into the original function, then plug in our two endpoints, and then just compare those values. Let's do it. Start by just taking the first derivative. That'll be 3x squared minus 2x minus 8. That's our first derivative. Set that equal to 0. There we go. I believe that should hopefully factor. Let's find out if it does. 0 equals 3x and x. Let's see. It looks like we have 4 and 2. I believe we can make that work if I put the 4 here and the 2 here, because that'll be 4x and 6x. So that's good. I need the 4x to be negative and the 2 to be positive. All right, so there we go. We have 3x minus 4 and x plus 2. I believe that, double check, that does in fact work out. Except no, it doesn't. I got my negative sign backwards. So that should be the plus, and that should be the minus. So you always got to love factoring these quadratics. All right, hopefully that looks a little better. 4x negative 6x gives us negative 2x. All right, there we go. If I set both of these equal to 0, I will get negative 4/3 and 2. So there are two candidates for when the maximum or minimum occur, negative 4/3 and 2. All right, so what we need to do is take these 4 points, negative 2, negative 4/3, 0, and 2. Because of the way the absolute max and min works, these are the only 4 candidates in this interval for the maximum and minimum of this function. And if you think about that, that's kind of amazing. We've taken an infinite number of points and narrowed it down to 4 that are either the absolute maximum or the absolute minimum. Now all you got to do is just plug all 4 of these points in one at a time and see what their y values are, and from there just see what's the max and min. Let's do it. If I plug in 0, I get 0, 0, 0, 4. So f of 0 is 4. If I plug in 2, I get 8 minus 4 is 4. Minus 16 is negative 12. Plus 4 is negative 8. So if you're not sure about that, just double check it on your own. If I plug in negative 2, I get negative 8 minus 4 plus 16 plus 4. So there, that's going to be 20 minus 12 is 8. And if I plug in negative 4/3, that's equal to negative 1.333. So I'm just going to do that on my calculator real fast. So negative 1.333. Hang on, I feel like I've made a mistake. Do you see the mistake I've made? No, I think we're okay. We'll keep going. So negative 1.333. We will take that to the third. Then we'll do minus. Oops, I lost my minus sign. And then we'll do minus negative 1.333 squared. Ooh, I need to be careful there. Make sure you're careful with your parentheses. Minus 8 times negative 1.333 plus 4. And we get this number, which is about 10.518. Alrighty then. Now, if you were to do that as a fraction, you would have gotten the following. If you had written it out as fractions, you would have received the following, which is 284 divided by 27. So our decimal is pretty close. So as you can see, this is definitely our maximum value. This would be our minimum value, except one really important thing. So notice that this is our minimum value, but look, is 2 in our interval? No, it is not. 2 is not in the interval, so we can throw that one away. In fact, I didn't even really need to plug 2 into the function. The only 3 we care about are the 3 that are inside of our interval. So the function does go lower later, but we don't care about that because we're only looking at this interval. So what that means is that the minimum is 0. So here's our maximum, our absolute maximum. Here's our absolute minimum. And that's because even though the function goes lower in other places, all we care about are the 3 values that are in our interval when we're doing this. So be careful. When you take your derivative and you get a value that's not in your interval, when you set it to 0, you can go ahead and kick away that value and you don't need to actually check it. That's it for now. In the next video, we'll look at another example.